Hey, welcome back to Common Sense OT Security. A couple of days ago, CISA published a guideline called Principles for the Secure Integration of Artificial Intelligence in Operational Technology. And we'll check it out today. I'm going to give you my opinion. But first, let's just quickly think about why now. What does this tell us? Well, I think it tells us that AI is definitely getting traction in OT. And I don't know about you, but I can tell you it did surprise me because I'm on the record 2 years ago, we're in a live discussion called, and you can see that on our YouTube channel. There is this recording from 2 years ago titled "Is AI the Future of Control Engineering and OT Security?" And 2 years ago, I pretty much made the point, well, it's probably too early, as at this point in time, it won't have any significant impact. But obviously, the world has changed. AI does already have an impact in OT, if only in the way that I would imagine most engineers, most practitioners, most IT people who are in charge of OT in some capacity are just checking out what they can do with AI. And maybe the easiest explanation would be the success of the large language models of those platforms such as Grok or such as Claude. So this is, in my opinion, what drives this whole development. And why not have CISA step in and provide some guidance for the principles of secure integration of AI in OT. And this is another document that seems to be co-authored by a couple of government organizations. You have seen that before. I've discussed similar papers already. Looks like this is the Five Eyes plus Germany. So there seems to be some collaboration going on. They have already published a couple of guidelines on various topics that I've discussed here in this webcast, and now they published this one on AI in OT. So let's check this out. A table of contents, scope, types of AI technologies, blah, blah, blah. And then the bulk of the paper is those 4 principles that they suggest you should use for making secure usage of AI in OT. Let's jump into the introduction. AI can potentially be used to increase efficiency and productivity, enhance decision-making, save costs, and improve customer experience. I would say, yes, that's spot on. I see it in the same way now with all those dramatic improvements that we have seen recently in the AI space. I think that's a valid proposition. But despite the many benefits, integrating AI into OT environments also introduces significant risks. Is that true? Such as OT process models drifting over time or safety process bypasses. So that is one thing. Unfortunately, I have to say, well, guys, you're about to lose me here, because if I can see one thing, it would be potential safety process bypasses. So just for anybody in IT, so if you're not a control engineer, please get it in your head. Safety is a very specific so the safety means risk to life and limb. And in any scenario where that is a thing, you have to use dedicated architectures and equipment. And nobody in their right mind would ever use AI in that capacity. I'm saying at this point in time. So I don't know, maybe things will look differently in 5 or 10 years, but at this point in time, no, you will never get anything certified that is AI related. And why? Because especially safety is totally deterministic. So in my opinion, a little bit weak entry here. The other thing that I would like to point out, they are talking to critical infrastructure owners and operators. Well, probably in a logical way, because CISA addresses critical infrastructure. However, I would say the whole topic and also the argument they are making certainly is not limited to critical infrastructure. It certainly applies to OT overall. Okay, and then they give us a brief idea of a brief overview of those 4 principles that they explain in more detail in this paper. First is understand AI, and then consider AI use in the OT domain. And again, in my opinion, a little bit weak, because understand the unique risks and potential. So here is how I see that. Presently, the people who are experimenting with AI in OT, well, they are pretty much on top of it, right? So you don't need to remind them, well, you got to understand AI. Well, okay, we are in the process of developing that understanding, and we are already considering AI use in the OT domain. So again, that's a little bit flat in my opinion. Then they come with established AI governance and assurance frameworks. Okay, we'll look at that and embed safety and security practices into AI and AI-enabled OT systems. Again, I have an issue with safety. I would leave safety completely out of the equation, because if it's not deterministic, then you no longer have safety. And in a way, this also applies to control as such. Control needs to be deterministic, otherwise it's no longer a control. But we'll get to that later. So, and the one thing that I'm missing here in this introduction would be a brief intro into the question, well, so this is about cybersecurity risks, or suggestions on how to minimize that risk. And what I would like to see here is, so what is that risk? What risk could be associated with bringing AI into OT environments from a security perspective? And unfortunately, they don't explain this in any easy to digest form. So that risk that they rub in your face in the intro is scattered throughout that document only in an anecdotal manner. And for that reason, I would like to pause here with a guideline for a second and just get you to consider, well, what would that risk look like? What could it be? And I think it's pretty easy, if you ask me. And I would guess that everybody who is in that same stage of presently experimenting with AI, it's not very difficult to explain. So first of all, the risk that comes with using AI in its present form is that you are urged to expose your stuff to a cloud service. That cloud service could be ChatGPT, it could be Claude, it could be Grok or Gemini or Microsoft Copilot. And that obviously comes with the risk of your data security, because well, you can make a good argument that you want to keep that data private. And with most of these platforms, you don't have that choice presently. And I think this is going to be a very interesting experiment, a social experiment, if you will, because you know that I would say the majority of OT asset owners have a lot of reservations about putting any of their OT or process-related data and secrets funny enough, that every now and then that changes when some vendor has managed to convince, mostly the sales people of such a vendor has convinced management, all those benefits, cost reductions, etc. And then in some cases, all of a sudden it makes click and all those reservations go away. And then you have, let's just say, your whole IT infrastructure in ServiceNow, in the cloud, or in Splunk, or you name it, right? And I could imagine that the same thing might happen with AI applications. I mean, think about Clarity, think about Nozomi. Your data is in their cloud, in regular installations, right? So my point is, sometimes you can see there is this tipping point where a vendor convinces the customer enough that, okay, now here you have our data. But it doesn't have to turn out that way. And I believe the risk in respect to AI is a very specific one, because there is this concern that your data, your OT infrastructure information, your confidential process information, etc., might be used to train the public or proprietary AI, however, no longer your AI, but some other company's AI. It might be used to train that AI and make that additional intelligence available to other customers, including your competitors. That is not a very attractive proposition. So therefore, this is how one of the biggest problems that I see presently for AI adoption. You don't want to put your data in the cloud. And as it stands presently, the bulk of those services and those offerings come with that architecture. And I mean, for some funny reason, it's not addressed in this particular guidance from CISA, but they talk about large language models. So therefore, I just assume that they also imply that this is going to be used. The whole AI processing will be done in the cloud. And so this is one cybersecurity risk that I see. And the other cybersecurity risk that I see here is that, and it ties to my remarks about safety. At any time you would use AI for real-time control, basically you no longer have control, because it's no longer deterministic. Because you cannot, let me put it this way, the way or why AI has arrived at certain decisions can usually, at least not with the prevalent AI that we are presently seeing, can usually not be explained by reasoning, right? So you cannot validate it, you cannot verify it by going back to first principles, by coding restrictions, etc. So, and therefore, for that reason, I see that as a very important cybersecurity risk, because you may no longer be able to predict your process behavior if you push over the control authority to AI. So I think that's a very important problem that we are potentially facing. I say potentially because, to my best knowledge, this is presently not happening. I haven't seen it. So AI is not used for real-time process control. There are some intermediate steps that, in my opinion, also yield very attractive use cases. So just consider that the AI generates your process logic, your ladder logic. Just like you see it in IT presently, in software development every day at a large scale. So you let the AI write your code, and that works just like a charm. And this is one of my predictions. I predict that this will also happen with ladder logic. So the ladder logic will be written by AI, and then you don't have that problem, because a human can still validate that ladder logic before it is executed. Okay, so let's get back to the document. Terminology, we don't need that. Scope, types of AI techniques, also machine learning, we know about that. And then they talk about large language models. I've mentioned that earlier. And those large language models usually run in the cloud because is that they don't talk about local AI, which would most likely involve small language models. So that is going to become a thing that's presently a very important development. Just if you take a step back here for a second. So why would you need a large language model for your OT applications? And I would imagine that most people do. Then I can chat with my OT infrastructure. I can ask it questions about the any process deficiencies or whatever. And I think that's a very weak use case. And I'll tell you why. There are two problems with that. First of all, for this limited scope. So let's just say you really want to be able to chat with your OT and ask it questions. So where do we see, did we see reduced efficiency after that firmware update or network reconfiguration, etc.? In order to do that, you don't need a large language model. The large language model contains all kinds of crap that you don't need and don't want in that scenario. So the large language model would be able to tell you about history and poetry, and so certainly something that you would not want to, that you wouldn't be interested in this scope. And in order to get rid of that, you would use a small language model that is specific to your domain, and that you can interact with in respect to anything related to your process and to your OT, but it wouldn't be able to tell you about poetry. So that's the big difference. And unfortunately, they don't address this. The other thing that I don't really see is obviously, so chat applications have boosted this whole AI development, but I don't necessarily see that as a strong use case or scenario going forward. Because I mean, we had a couple of discussions with our customers. Wouldn't you like to go so chat with your OT inventory, right? OT asset inventory? And at the end of the day, the answer was no. Why would I want to do that? Because if I just go to OT base, I can get all my questions answered with 3 mouse clicks. So why would I work the keyboard and write English language sentences? So that is, in my opinion, it's strange that they focus on LLMs here. AI agents, okay. AI applications according to the Purdue model. Guys, I don't need to remind you what I think about the Purdue model. If it makes you happy, use it. I would not have used it here. So what I think the takeaway here is in this chapter, they address a couple of use cases that they see. AI for local control, like local anomaly detection, okay? And quality control to detect early signs of equipment anomaly. So I don't want to bore you with the details, and in my opinion, they are really boring. So in my opinion, this could be used as a stimulus for thinking about, well, what actually are use cases? What are interesting use cases for AI in OT? And if you ask me, those use cases basically fall in 2 different categories. So the first category would be analytical. You throw a ton of data at the AI, and then the AI makes some decision, like that's good or bad, right? Pass or fail. And one of those use cases would be anomaly detection, and certainly including network anomaly detection, as you see it in the threat detection products. Okay, I think that could be boosted by AI, by throwing the AI at it, hopefully in order to reduce the very high rate of false positives that you are presently seeing. So that's one area, and certainly you could extend that to predictive maintenance, right? So predicting if and when a particular piece of equipment is going to fail. That is an analytics. And then you have a second area of use cases that for some funny reason doesn't seem to be addressed in our document here, and that is generative. So anything that that the AI can generate for you, and it's not just a pass or fail decision, it's just an artifact that is a little bit more complex, and that could be, for example, your control code, your ladder logic that you then load on the controller and then see it do its thing. Cybersecurity risk assessment. Don't you think that can be done? Oh, absolutely. That can be done very well. Because if you have all the required data, which you do in OT-based, so like with the asset inventory, with the vulnerabilities, with the data flows, with everything, then the AI can spit out a cyber risk assessment, certainly. And like, I don't know, 50 pages, 100 pages, 500 pages, if you want to be more verbose and just kill the regulator, just DOS the regulator. Yeah, that can be done, and I predict that's going to be a thing. Again, so they don't specifically mention that, but this is what I believe are interesting upcoming use cases. I don't see once more that a chat application or chat scenario will be an interesting upcoming use case. Then now here is the start where they go into more depth regarding those various principles. Okay, and again, I've mentioned already, understand AI. Okay, we are already doing this, but however, what makes this chapter a little bit interesting is that they also point to specific AI risks when discussing those principles. And let's see what we got here. So this is one thing that I mentioned earlier, lack of explainability, very astute observation in my opinion. Understanding an AI's model decision-making process may be difficult. I would say it often is impossible. I do see that AI is getting better and better at explaining this, but in many cases, but you're not able to actually understand how that decision was reached, or how that product came into being, right? And that is a problem specifically when you think about real-time control. And I mean, the easiest way to understand this is when you just consider all the hallucinations that you have seen. So if you have experimented with AI, you have seen hallucinations, and you will most likely have made identical experience like myself, where the AI totally convincingly tells you, oh, this is red. When you know it's not red, it's green. And then when you, in such a chat application, when you tell the AI that you challenge the AI, no, actually, that's not red, it's green. Oh, yes, you are right. Oh, man, AI, what's wrong with you, right? So just a second earlier, you convincingly told me it's red, when now you know and agree it's actually green. So that still is a problem. It could go away over time. We'll see. The next thing I also think is very real. Operator cognitive load and unnecessary downtime. AI may generate alarm errors that could cause unnecessary downtime or safety incidents. Guys, get out of here with the safety incidents. But the cognitive load, I think that's a real thing. And we see that already with OT threat detection applications. I mean, if you're getting dozens of alerts each day, and they turn out to be false positive, every single one of them, you're not only overloading the operator, you're also totally killing the credibility of your whole value proposition, right? And then certainly users will choose to ignore those alerts. And that is a risk that I also see. I don't see how this would be related to cybersecurity, but anyhow, it's a valid point. AI dependency, yes, I also see that happening. Over-reliance on AI can lead to operators missing critical safety-related information. If the AI misses, okay, you know that from your GPS, right? So for the old farts around like me, I grew up at a time. So I'm old enough to remember when there was no GPS in your car. So I really had to use maps, physical maps, like little printed maps, printed on paper in thick booklets. And then after a GPS was introduced and everybody was using it, it became commonplace that people got completely lost when the GPS happened to not really work. And yeah, the same can and probably will happen in the AI area. And I think there is a point to be made that the more AI you use, the dumber you will get, because you start to lose all cognitive skills. And next risk: interoperability issues. Integrating AI systems with existing OT can be complicated by interoperability changes. I don't buy this point. This is like a solved problem here. There are these interoperability issues no longer exists now that certainly. So that's new stuff. Like a couple of months ago, I think it was, when Anthropic introduced their model context protocol. That's a solved problem. So presently, and I imagine going forward, everybody uses MCP. So you have one standard protocol. It's similar to MQTT in other areas in OT. And so I don't see that as a risk, and we could simply strike that. Reliability: AI may not be reliable enough to independently make critical decisions in industrial environments. Absolutely, AI can hallucinate, and we have talked about that already. Understanding the secure AI system development lifecycle. Critical infrastructure owners and operators should verify that the AI system was designed securely and understand the roles and responsibilities through the AI system's lifecycle. Well, that's a great idea. However, I don't see it happening. Why? Because especially if you think about the critical infrastructure. So if you would say, well, think about global manufacturing, or I don't know, IT departments with 100 guys and gals, right? So they could probably just start a project to understand the secure AI system development lifecycle. I don't see how your prototypical critical infrastructure owner and operator could pull this off. I think of your power plant operator, or your municipal water facility. So this is critical infrastructure, guys. So and they don't have the resources, they don't have the education, the nerve. so for me, that's a well-meaning but totally impractical principle here. So for that, you would need to rely either on the vendors. And I think that they will make that point. Well, you're buying from Rockwell, or you're buying your AI from Siemens, and we have taken care of that. All those designs and the life cycle, that is all secure. At the end of the day, you just have to trust them. It's as simple as that. Blah blah blah. Critical infrastructure should carefully evaluate the trade-offs between different methods for sourcing an AI system. Again, this, in my opinion, is sounds overly complicated because presently this is the Wild West in AI. Presently, we are just figuring out what works and what doesn't, and we don't know. Nobody has the nerve to approach this as something that will even where you say, well, this will definitely stick around for decades, so we would have to do our due diligence. So I think for the majority of OT owners and operators, they still have not a good idea how to actually employ this new technology and what to do with it. So again, I think that's well-intending, but not really practical advice. Educate personnel on AI. Well, good luck with that. when you think about your I don't know, machine operators or your control engineers. Oh, so good idea, but the resources aren't there. Consider AI use in the OT domain. Before owners and owners should assess if AI technologies are the most appropriate solution for their specific needs and requirements. And again, this is starting to piss me off because honestly, we don't know yet. I think nobody knows. Certainly, the salespeople will try to convince you, oh, it's so much better than those conventional technologies. But in reality, we don't know. So we have to check it out, and you don't have to, but presently many people are checking it out. And for that reason, all those considerations are a bit premature. So we are running out of time here. It goes on and on and on in that same fashion. And here is my bottom line. So in the meantime, I've just scrolled through all those other pages. Here's my bottom line. I think they failed, CISA and whoever of these other organizations have created this guideline. They failed to actually live up to expectations. And I wouldn't even know. They don't. It's premature. They don't need to do that at this point in time. I think it would have been better to compress all of this into a very short paper, maybe 3 or 4 pages would have been more than enough, and highlighting the bigger issues here, like I tried to do in the beginning, or I said, well, you're actually facing 2 types of risks. One with the cloud-based installations, and the other with letting the AI perform real-time control logic, where when it actually happens, it might be too late. You have no means to actually check. You're losing the predictability. That's the major argument here. You cannot predict what the AI is going to do. And the way to prevent this from happening is to let the AI produce this intermediate step that would be the control logic, or it could be the system design, for example. You can have the AI generate your specification for a new machine line, just like that. It's all in there in OT base. And rather than having a team of engineers work, I don't know, a week or 3 on that, you can do that. It works pretty well, but certainly you need to check the output against your requirements. And the same would be true for your control logic. You need to review the code. But then on the other hand, and that is, I believe, an interesting proposition to consider. It's you have to review that code and the design, etc. Yeah, but you have to do that anyway, even if a human does it. And so that is best practice, right? Before it's even part of change management procedures, right? So if you're doing it right, you're doing that anyway already, hopefully for years. You have this defined process where before you actually go to production, you review if it's according to specification or according to requirements. And that is not very different from using AI. So In that respect, so that would be the gist of a paper that I would have rather liked to see. I think this guideline is overly complicated, lengthy, long-winded, boring, and veering off. So, in this man's opinion, that's a fail. And but let me know what you think. Just drop a note in the comments below, and maybe we'll revisit the topic and see what other people can get out of it. See you next week.